is the third type we are going to consider in under the session keys. The underlying MAC layer uses names for both PTK and GTKs. This name is referred to as temporal key ID and is present in every secured packet sent between host and device. If you remember that packet structure of the general packet structure of wireless USB packet, first what will have preamble, right? So after that file header, then MAC header, then HCS. After that we will have MAC payload, right? Then FCS, all these things, right? In that MAC payload, first we will have security field. In that security field we have further some subfields. In that one field is TKID. This is the temporal key ID. Okay. In the device we may have so many so many keys. Each device will have ID 0, 1, 0, 2 like that. Okay. So how the host will indicate that now we are going to use this key. For example, the key which is in third line. So it's having its own ID number. So it will send that ID here. That is known as names for session keys. TKIDs identifies the keys used to encrypt the secured packet. The host is responsible for creating TKID values and supplying these to the devices at the time of key derivation or key distribution. Okay. Then fourth type of session key is the key confirmation key, KCK. It's a short-lived key, we know that one, used for message integrity during authentication. In authentication process we have to calculate the MIC field, right? During that time what key we will use? This key confirmation key. Getting? At the end of four-way handshake only we will derive pairwise temporal key. By using that we will encrypt the data and we will calculate the MIC field after the four-way handshake process. But during that four-way handshake process we have to make our packet secured, right? By using what key? That key is known as key confirmation key. Okay. It is also a 128-bit key derived and used during the authentication. It is discarded upon completion of authentication. Okay. So we know that authentication process is nothing but a four-way handshake. Okay. In the four-way handshake, in a first phase, four-way handshake is nothing but four phases of handshake. In our first phase, host will send some CDID and some information. Okay. So after the reception of that first packet, device has to calculate the pairwise temporal key and it will calculate the MIC field. Okay. Then it will send that MIC and along with that MIC field it will calculate KCK also. KCK is nothing but key confirmation key. Now it will send that KCK, host ID and derived key. It will send that MIC. In third phase what will happen? Host has to derive the same pairwise temporal key. Okay. And it will cross check the key confirmation key derived by device is same as what it has derived, host has derived. If both are same means pairwise temporal key is also same. Now in the next coming session it will going to use that pairwise temporal key. In the fourth step it will give acknowledgement or it will ask the device to install that derived pairwise temporal key. Okay. Do you have any doubt? So this is all about four types of session keys. So far we have discussed master keys and session keys. Under that master keys we have seen three types of master keys. Under the session keys we have seen four types of session keys. Session keys are short lived, master keys are long.